Okay, all right. So let us begin this session. And today we are going to have session number 8. And in this session, we are going to solve problems based on the power distribution system planning, both the economic aspects and solution strategies. And in the last session, we have solved problems based on the reactive power compensation in distribution systems. Krishna Kumarji, please turn off your mic, otherwise I have to remove you from here.
Turned up, sir.
Your mic is not turned off. From here, like it's turn off your microphone, just click on it. Otherwise, you can join later if you are not able to do it. Okay, all right. So today in this session, we are going to solve problems based on the reactive power compensation. Reactive power system. Sorry. In the last session, we have solved problems based on the reactive power compensation in distribution system with the help of shunt capacitors. Now in today's session, we are going to solve problems based on the power distribution system planning, both for economic aspects and for different models and solution strategies. So let us begin this today's session. I think one problem in your current assignment, that is assignment number 9, one problem is based on the embedded, marginal, and incremental cost. And it may not have been discussed in the uh, in the lecture slide. So I have just briefly explained about the embedded, marginal, and incremental cost. So here, this is from the book H. Lee Will's Power Distribution Planning, and here this figure shown over here is for the hourly cost of losses for power shipped through a substation transformer as a function of the load. Currently loaded to 45 MVA, it has embedded losses of $1.73 per MVA and a marginal cost of losses at the same point of 3.70 per MVA. The incremental cost of losses for an increase in load to 55 MVA averages 5.90 per MVA. So these are data given for a example. So let us see what this means: embedded cost, marginal cost, and incremental cost. So somehow if you see from this figure, embedded cost moreover represent like an average, while this marginal cost refers to a certain point, while this incremental cost refers to if you are having a step change or a step up or step down. If you are having if you are having a level change, then it refers to incremental cost. So let us see this definition. Embedded cost is is that portion of the cost that exists in the current plant system or configuration or level of use. Depending on the application, this can include all or portion of the initial fixed cost and all or parts of the variable costs. So, so immediate cost is that portion of cost that exists in the current plant system or configuration or level of use. And for this, depending on the application, this can include all or portions of the initial fixed cost and all or parts of the variable costs. So this embedded cost include all or portion of the initial fixed costs and all or parts of the variable costs. While this marginal cost is the slope of the cost function at the current operating point. So here in the figure you can see This marginal cost refers to, I think, 45 load 45 MB. So this point is usually not at the point at which current embedded cost is defined. Now, this incremental cost is the cost per unit of a specific jump or increment. For example, this incremental cost of serving an additional 17 MVA from a certain substation, or the incremental cost of losses when load on feeder decreases from 5.3 to 5.0 MVA. So this, as I told you, this incremental cost is the cost per unit of a specific jump or increment. And this marginal cost and incremental cost both express the rate of change of cost with respect to base variable, but they can differ significantly because of the discontinuities and non-linearity in the cost relationship. Therefore, it is important to distinguish correctly and use the two. And in the example that I have shown in the first figure, here if we refer to this figure, the marginal cost has a slope and an operating point, while this incremental slope has a slope and both from and to operating points. So that is the difference. So the marginal cost is defined as the load 45 MVA, while this incremental cost has a slope and also it is defined for this from and to operating points. That is 45 MVA to 55 MVA, or an operating cost and increment that is 45 MVA plus 10 MVA increase. So if you see in this figure, this marginal cost is defined at this point 45 MVA load, while this increment cost defined this for this increment of load from 45 MVA to 55 MVA. I hope this data will help you in solving one problem from this current assignment that is given on embedded marginal and incremental cost. And these all definitions have been taken from the H. Lee Will's book Power Distribution Planning. Now coming to one of the important expressions that we are going to use for this solving the current assignment, that is present worth factor. So whatever the price we are having, whatever the price for any certain thing, whatever investment you are doing, that same amount will have in the not the same value in the future. So it is having how we can relate the present worth of money with the future worth of money. And for that, this present worth factor plays an important role. So present worth factor is related to discount rate as 1 divided by 1 plus D, where P is the present worth factor and D the discount rate. And here we have assumed FW means that value of money required for T years later, and PW that means present worth with the present value of money required for the expansion planning. So this expression we are going to use to see the value of money, to see the uh, difference whatever the money of value in future. So based upon that you can decide whether should you invest right now or you should invest later. So this just help you taking the economic decision. So this present worth and future worth, it provides you how you have to decide economically so that whatever you have to invest right now or you have to invest later. So this is present worth and this is future worth. There are many ways they have in different books they have uh, expressed this equation, but just you have to understand in any way you can express and use this formula for solving the problem. Now another expression is that levelized value. So levelized analysis is a method of applying time value of money analysis to initial and future cost to develop an equivalent constant annual cost. So this is like whatever the investment fixed cost and this variable cost, whatever the cost is happening during this during over a period of time, you can see whatever the levelized value means whatever the constant annual cost for this investment. So this is like a this is like a constant straight line over varying the investment and cost for the equipment. And how you can find this levelized value for a certain amount q, levelized value of q for t years, that is comes as q into d1 plus d power t upon 1 plus t to the power t minus 1, and here d the discount rate and t the number of years. So
Sir, what is Q?
q is the whatever the value of money right now, the present worth. So this is q is the present worth. So this is all for this eco power distribution system planning for economic aspects. And now for this coming to this different models and solution strategy, in that optimization plays an important role. And here this what is the goal of optimization? The goal is to either to maximize or to minimize certain objectives, which can be translated to some mathematical functions that are called objective function. And this objective function can be divided into two types: single objective optimization function, and the second one is that multi-objective optimization function. And in the single objective optimization function, like you have to minimize fx, that is single function only, and where this x is called decision vector, which consists of number of decision variables. It is also called as optimization variables, problem variables, or simply variables. So x can be a single variable also, that when this x will be single variable, at that time we call it as single variable objective function. And when x will be n-dimensional vector, at that time we call it as multi-variable objective function. Sorry, your mic is again turned on. You should not keep it on continuously.
That is new mobile, sir. I don't know how is that.
So you can ask someone, and you can just I suggest you to you batch it later, because it will create problems while recording, and we cannot have a good recording. So right
Yes,
now,
yes.
sorry, I am removing from the lecture, and you
Okay,
can.
okay, okay, okay. Okay, remove.
So sorry guys for this. So we are here, and if x having n-dimensional vector, then it will be called as multivariable objective function. Now, second type of objective function is that called multi-objective optimization function. If you are having n number of objective function, and in that case you have to minimize or maximize this f1x, f2x, and it goes to fnx, like that. And in this assignment, I think single objective optimization problem has been discussed. Until here, the questions have been asked to the current assignment. And for the single objective or mono objective optimization problems, there are two different types: unconstrained, that is minimized fx, In that we have, there is no there is no constraint for this type of optimization problem. While this constraint optimization problem, you have to minimize the function with respect to sub constraints, and these constraints may be having equality nature or inequality nature. It is simple from the term itself, like for equality constants, these are equal to 0, otherwise it is having greater than or less than equal to 0, that means it inequality constant. In constant optimization problem, the solution which satisfy the constraints are called feasible solution, and the best feasible solution in view of the objective function is called the optimal solution. So whatever solution that you got and this satisfy these constraints, that are called feasible solution, and the best feasible solution among all is called this optimal solution in view of this objective function. And for optimal solution, there are two types: local optima and global optima. Local optima, it means that the best solution among its feasible neighboring solution, while this global optima, the best solution among all the feasible solution. Now, the optimization problems can be divided based on the natures, like if you divide into linearity, then you are having two types, linear and non-linear. And based on the convexity, it is of two types, convex and unconvex. And based on differentiability, differentiable, non-differentiable. And based on the nature of decision variables, it is of continuous, discrete, or mixed integer that includes both continuous and discrete variables. And there are different ways to solve the optimization problem, and you may divide this solution strategy in two types. One is mathematical logic based algorithms, that is deterministic logic based algorithms, and it is of, and examples for that are given: mixed integer programming, branch and bound, Bender's decomposition, dynamic programming, nonlinear programming. Another way you can meta heuristic algorithms, in that include expert system, branch exchange, network flow programming, simulated annealing, and the and one of the famous and widely used, that is population based meta heuristic algorithms, in that include genetic algorithm and colony optimization, artificial immune system, and particle swarm optimization. So for this solution strategy, in most of the multi-objective planning, the population-based meta-heuristic algorithms are used because this multi-point search helps to obtain a set of Pareto approximation solution in a single run, and they can also handle nonlinear, non-convex, non-differentiable problems effectively, and they also don't suffer from the curse of dimensionality. And a major drawback for this population-based meta-heuristic algorithm is that the convergence is not always granted. So till here, any doubt? Otherwise, we can start to solve the problem. This is a quick recap about the lectures, that most of the uh, problems have been asked from these portions. So let us see the first problem, and whoever is getting the answer, you can type your answer in chat box. A utility needs rupees, how much it is? It is, I think, 10 lakh. 10 lakh right now to do expansion of a substation. How much money will be needed 5 years later to do the same expansion? Assume the discount rate as 10%. So, so present worth of money is given as rupees 10 lakh, and time number of years is given, that you denote it by 5, that is given as 5 years, and you have to determine this future worth and discount rate is given as 10%. So take it as 0.1. So we know the relation present worth equal to future worth into this p to the power t, where p is the present worth factor. So p present worth factor is denoted as 1 upon 1 plus d. So you have to just put all these values to get the answer. So it will be 1.1 to the power 5. So it will give you 16 lakh 10,510. Yes. So therefore C is the correct answer. Yeah, Rahul, you are correct. Yes, correct. C is the correct answer. One doubt whether present worth factor is 1 upon 1 plus t upon t or just 1 plus t upon t. Only when I see solving using 1 plus dt, answer is solved. So this one is correct, 1 upon 1 plus d to the power t, not 1 plus d upon t. So either way, means one common way to verify your answer is that it should never come below the present worth. Future worth of money will always be greater than the present worth. So don't confuse. If you are getting answer below than present worth, then you are certainly doing something wrong. And why this somewhere present worth factor is denoted as 1 upon 1 plus d, and somewhere it is represented as 1 upon 1 plus d upon t. So in the book also, if you see, they represent present worth factor somewhere like this. So this is also correct because if you take t equal to 1, then it comes the same. So at the time they are defining the value of money after 1 year. And if you like if you take t more than 1 or something, like, it is the generalized form. So the value of money for any is after a certain year, then you can find the future worth of money. Somewhere you can also see this one, this expression also, but we are not using it. I am not using it. If you are using this, you have to just be careful. Then you have to not use here p upon t, p to the power t. You don't need to use. So there is nothing no, that much to like confuse about the expression. You have to just look upon the concept, that how we are getting the answer. Like, future worth cannot be less than this present worth. If you are getting it lower, then certainly you are doing the some wrong expression you are using. Okay, so let us move to the next problem. In this problem, if a substation expansion requires rupees 15 lakh 5 years from now, what is the discount rate if the present value of this money is equal to 9 lakh? So here you have to find the D. If the present worth of money is given as 9 lakh and T is given as 5, that is number of years, and future worth is given as rupees 15 lakh. So we are we know the expression is present worth is equal to future worth into p to the power t, p upon t, and p is the present worth factor. It is denoted as 1 upon 1 plus t, where d the discount rate. Now substitute all this value. 1 up plus d upon 5. So it will come 1 upon d to the power 5. It will come 5 upon 3. So 1 plus d will give you 1.10757 and d equal to 0.10757 or 10.757%. Therefore, A is the correct answer. Yes, A is the correct answer. Option A, 10.756%. Today attendance is less, but Priyadarshini and Rahul, only both, only two are present. So let us move to the next problem. So in this problem, the present worth of a distribution network planning is given as 12 lakh for a planning period of 5 years. What will be the levelized cost for this planning? Assume discount factor as 8%. So I have mentioned one point that levelized value of Q, this present worth over T years, is given as Q into in numerator D into 1 plus T upon T, and in denominator 1 plus D upon T minus 1. So here in this problem, T is given as 5, Q is given as 12 lakh, and discount factor is given as 0.08. Just put all this value, you will get the answer. 12 lakh into discount is given as 0.08 into 1 plus d upon t, 1.0.8 upon 5 upon 1.08 upon 5 minus 1. So it will give you 3 lakh, 3 lakh 547.74. So B is the correct answer. So now in this question, if you see, you can clearly say that two options will never be going to correct, like this 17 lakh and 12 lakh, because these values are greater than the present worth, and this levelized cost, that is the average annual cost, so it should be very lesser value in comparison to the money. So it is coming as 3 lakh, 3 lakh 547, and this is also moreover 8 lakh 16,699. So from the options you can easily predict. If you don't have enough time, you can also predict that which option is going to be correct based on your understanding. The next question is that present worth analysis can be beneficial for, and the options are reducing the power demand in future, reducing the maintenance cost, timing of investment, and D, all of the above. So what do you think? So which option should be correct? Is Priyadashini. For third question, B is correct. And now for this question, what should be the correct option? So what do you think? Which option is correct? Rahul Pirdasani. Rahul, you are saying D. So D is not correct.
Option C, timing.
Yes, option C is correct. Timing of investment. Option C is correct. Why? As I told you, this has nothing relation with any of things like we are doing any reduction or any whatever power demand or maintenance cost. Any we are nothing. We have to just decide that whether we should invest right now or we should invest in future. Like if certain things you have options, like it is not necessary to invest right now, you can invest in future also. If something is compulsory, then anyhow you have to invest right now. Otherwise you may decide what should be the correct amount of time to decide then whether when I have to invest. So this tell you the timing of investment. So C is the correct answer. I think sir has covered this portion, whether you like you have two transformer and you have to install one and one may install in other time also, so you have to you have to manage, like right now you have to just put into the network, or you can put in the put in the network later. So present worth analysis is a method of measuring and comparing costs and savings that occur at different times on a consistent and equitable basis for decision making. So the major factor is that you have to, it gives the, it gives the, like it decides, it helps you in the decision making for the time of investment. And the next problem is that one step planning which does not consider load growth is called, and the options are dynamic planning, contingency planning, expansion planning, static planning. Any idea? Since two persons are present only today, so you can turn off your mic and speak whatever what is the correct answer. If you have not gone through these lecture slides, then it's difficult, because in the lecture slides it is given that distribution system planning has been divided into two types: a static planning and dynamic planning. A static planning, we don't consider the load growth, while the dynamic planning, we consider the load growth. So here, if you see in this problem, it asked about the in which is the one step planning which does not consider load growth. So correct answer will be D, that is static planning. And further, for this dynamic planning, we also decides that load growth we want in existing network or we are adding some new nodes that comes under the expansion planning. Now the next problem is that which of the following are the meta heuristic optimization approaches? And this is multiple select question. More than one options are correct.
Particle swarm and ant colony.
Yes, very good, Rahul. So B and D are correct. Multiples. Minute. So you can see the different classification of solution strategy. From this diagram, you can clearly say that this for meta heuristic optimization approaches, this particle swarm optimization, this particle swarm optimization, and this ant colony optimization. Now let us see the next problem. Which of the following is an advantage of meta heuristic optimization algorithm? And this is also multiple select question. More than one options are correct. So options are their execution time is very short. They sometimes provide only local optimal solution. They can solve non-differentiable objective functions. They can solve problems with large number of variables.
Option C and D.
Yes, correct. Option C and D are the correct. No, A and D is not correct. So they can solve non-differentiable objective function also, and they can solve problems with large number of variables. And this first option is not correct because this takes enough time to execute and sometimes hours or even days. So short execution time is not the property of meta-heuristic optimization algorithm. Now the next problem is that which of the following is not a deterministic optimization algorithm? And the options are genetic algorithm, Bender's decomposition, branch and bound, and dynamic programming.
Option A, genetic algorithm.
Yes, correct. Genetic algorithm is not a deterministic optimization algorithm because it comes under meta-heuristic algorithms. The next problem is that which of the following is not a distribution system planning problem? And the options are substation expansion planning, feeder expansion planning, conductor replacement planning, power plant expansion planning.
Option D, power plant expansion plan.
Yes, correct. So, Priyadarshini, if you have any doubt, you can ask. Otherwise, we are going in fast. So the next problem is that distribution system planning is generally a kind of mixed integer optimization problem due to involvement of discrete decision variables, continuous decision variables, both discrete and continuous decision variables, and D is both convex and non-convex objective functions.
Option C, both
Yes,
discrete and continuous.
is correct. Very good, Rahul. So C is the correct. Both discrete and continuous decision variables comes under mixed integer optimization problem. So for this, like from this assignment, generally moreover this type of problem only asked. So these are very simple. Now coming to the next part. So a substation expansion needs rupees 50 lakh after 5 years of nine. Now, how much money the utility should have right now to do the expansion? Assuming this account factor as 10%. So in this problem, the future worth is given is 50 lakh and T is 5 years. How much money the utility should have right now to do the expansion? You have to find the present worth and the discounted is given as 0.1 and present worth factor is denoted as 1 upon 1 plus D. Therefore, we can write the expression present worth is equal to future worth into P upon T. So future worth is rupees 50 lakh into 1 upon 1.5. So it is giving you rupees 50 lakh into 0.621. So it is coming as 31 lakh 4606. So this is the answer. So C is the correct answer. Yes, Rahul, you are correct. Priyadarshini, you are correct. Priyadarshini, now you able to understand this present worth factor you were asking initially. Okay, good. And if you have again doubt while solving the problem, you can ask in the discussion forum. That's very because all the NPTEL team members are present there. That is very good way to discuss anything. Now the next problem, a utility needs rupees 30 lakh right now to do expansion of a substation. How much money will be needed 4 years later to do the same expansion, assuming discount factor is 10%. So these are more of a repeated type question. Only the data are changing. So given present worth is given as rupees 30 lakh and number of years is given as 4 years and discount factor is given as 0.1 and present worth factor is denoted as 1 upon 1 plus D. So present worth of money equal to future worth into P upon T. So you have to find the future worth of money. So 30 lakh to future worth upon 1 plus 1 upon 4. So it will give you rupees 43 lakh 92,300. 43 lakh 92,300. C option is correct. Yes, C option is correct. And in this problem, if you see problem carefully, then this present worth is given as 30 lakh and all the options here given less than 30 lakh except one, that is 43 lakh. So without solving, you can directly tick one this because only one option is greater than 30 lakh. Because in the future, the value of money will be always greater than the present value of money. And the next problem is that if a substation requires rupees 40 lakh 6 years from now, what is the discount rate if the present worth of this money is rupees 30 lakh? So given present worth is 40 lakh and sorry future worth and present worth is given as rupees 30 lakh. So and t is given as 4 years. You have to find the discount rate. We know that present worth factor is denoted as 1 upon 1 plus d, and this present worth is equal to future worth into present worth factor. P is 30 lakh, P is 40 lakh into 1 plus 1 upon d to the power 4. If you solve this, you will get. So let us switch to the next session. Otherwise, we may miss how many times left. 10 minutes. So both of you please join through this new link and we will continue there. I hope you are able to see the screen. So we are here. So if you see, it will come. Sorry, D is given as 6 years, not 4 years. Why it is not? Now it is visible.
No, sir.
So I am again I am again sharing it. Now, Rahul, Rahul, it is visible.
No, sir.
Priyadashini for you. So for this problem, A option is correct. So let me check. Priyadashini, you are able to see the screen. Rahul, why you are not able to see the screen? She is saying.
Understand, sir.
So
Let me try one again.
you again log out and again
Yes,
come.
yes, sir. Yes, yes, yes. Yes,
Okay,
yes, yes.
okay, fine. So let us move to the next problem. So in this problem again, you have to find the levelized cost. So here, if this project worth is given as rupees 10 lakh and T is given as 5 years, what will the levelized cost for planning if the discount rate is given as zero point 0.1? So we know that levelized value of Q over T years is given as Q into D into 1 plus D upon T into 1 plus D upon T minus 1, and this is be called present worth as Q. So rupees 10 lakh into D is given as zero point 0.1 into 1 upon 1 5 upon 1 upon 5 minus 1. So it is given as rupees 10 lakh into 0.2637. So it is coming as 2,63,797. So here if you see this present worth of money is given 10 lakh and this period is given 5 years. So just to divide 10 lakh by 5 years, then it will come as 2 lakh. So moreover it will close to 2 lakhs. So one way you can also analyze. So this B is the correct answer. 2,63,797. And these two options A and D never going to be correct because see the same amount of money it is and 16 lakh is greater than it will also never happen. So both two options you can easily eradicate and one option two options depend upon the discount factor. So all we have seen also previous problem here we have to find the levelized cost, that is average annual cost. So average annual cost is moreover it should become near to the amount we have invested divided by this number of years. And the next problem is that present for factor needs to be multiplied with future non-recurring cost, future recurring cost, both future non-recurring and recurring costs, neither future non-recurring cost nor recurring cost. What do you think? Rahul and Priyadarshini, which option should be correct? Yes, B, not B is not correct. You are telling for previous problem or this problem? I think for previous
Previous
problem.
problem. Previous.
So of course, means both repetitive and non-repetitive both cost it include. So C option is correct. And this, if you see recurring cost and recurring cost refer to the expenses that is known, anticipated and occurs at regular intervals. That you may say it as repetitive cost. And the examples are cost to provide electricity to production utility, periodic utility expenses, routine class and marketing expenses, and depreciation expenses that are repetitive type of cost. While this non-recurring cost is one that occurs at irregular intervals and is not generally anticipated. And the options are restructuring cost, replacing equipment because we don't know when the equipment failure will happen, emergency maintenance expenses, expansion cost, losses due to natural disasters or other unforeseen expenses. So the present worth analysis includes both recurring cost and non-recurring cost. I think it has been discussed. The static planning of power distribution system is one step planning without consideration of load growth, and B option is multi-step planning with consideration of load growth. C option is contingency planning and D option is all of these. So what is correct option?
Option A.
Yes, option is correct. So static planning in which that is one step planning, we don't consider the load growth. While this dynamic planning of power distribution system, of course, it should be multi-step planning with consideration of load growth. So B the correct answer. And 18th number problem is that meta heuristic algorithm works with calculus based mathematical rules. Again, this is multiple select question. More than one options are correct. Nature inspired meta heuristic rules, iterative updating of randomly generated solution, and D option is non-iterative direct solution approach.
Option B is one of them out of two.
Yes, option B is correct. And this is also iterative iteration. So it is also comes, C is also correct. And calculation comes under this deterministic optimization algorithm. So these two are correct. B and C options are correct. Sorry. And the next problem is that the advantages of meta heuristic optimization algorithms are, and the options are, this can be used in solving nonlinear problems. Then this can be used in solving problems with non-differentiable objective function. This can be used in solving problems with large number of variables, and D is all of these. In most, sorry. So which option should be correct?
Option D.
Is correct. Because in most of the multi-objective planning, these population-based meta-heuristic algorithms are used at because this multi-point search helps to obtain a set of Pareto approximation solution in single run, and they can handle non-linear, and they can handle non-convex, and they can handle non-differentiable problems effectively. And they also don't suffer from the curse of dimensionality. But one major advantage is that they see not known they may not converge to the optimal solution. Now the limitation of meta-heuristic optimization algorithms are, and this is multiple slide question.
Option D.
This is multiple slide question, so more than one options are correct. So
Okay.
and the options are they cannot always provide global optimal solution. They sometimes provide only local optimal solution. The execution time is very long, and D is all of these.
Execution time is very long is one.
No, no, it's not correct. It is incorrect. It's not true that always it happens. So it is not a limitation. Means like you cannot tell that execution time is long. It's true that it's somehow it's long, but it is not like always long, always very long. So it is not correct. And this one is true because I told you now they may not converge to the optimal solution. So they cannot always provide global optimal solution. This is true. And they sometimes provide only local optimal solution. This is also true. So these are the limitations of the meta heuristic optimization algorithms. The next problem is that which of the following decision variables of distribution system planning problem is integer in nature? And the options are determination of optimal substance size, determination of optimal feeder routes, determination of optimal line conductors, and these all of these.
Option D.
Yes, option D is correct because these are all integer in nature. Substation size integer in nature, feeder routes is integer in nature, line conductor size is also integer in nature. Now we have come to the last problem, and the last problem is that which of the following is not a meta-heuristic optimization approach? And the options are genetic algorithm, particle swarm optimization, dynamic programming, and these all of these
Dynamic programming.
is correct. C is correct, and you can refer to this classification of solution strategy and this mathematical logic based algorithms. Here you can see dynamic programming comes under this mathematical logic based algorithms. Another genetic algorithm, this particle swarm optimization, that comes under meta-heuristic algorithms. In that it comes under population based meta-heuristic algorithms. So that's all for today's session. If you have any doubt, anything to ask, you can ask me. Rahul Priyadarshini. I think most of you were asking about this backward forward load shift method is how it is it can be used in unbalanced system or not. So yes, it can be also used. So many papers and even you see the Sanjeev Ganguly sir paper research paper how they have utilized this forward backward load flow shift method in unbalanced system. But that is true that in class and in this session we have discussed about the balance system, and for the balance system we have done this per phase analysis, and then we have find the single line diagram and then done the per unit system. So we can do for unbalanced system also. So that is true. Anything you need to discuss? So we have enough time, so you can ask, otherwise we can close this session. So Rahul, you are from electricity board, right?
Yes, sir.
And Pirdasni, you are from? You are in Maharashtra electricity board, right?
Yes, sir.
Mm. So okay, then see you later. See you then in the next session. Bye. Have a nice dinner and good night. Thank you for joining the session.